Nice launch trajectory countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence
7,
has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic. Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
T-minus 30 seconds.
All systems are go. Getting down to the final seconds.
15 seconds. T-minus 10.
10,
9.
9, 8, 7, 6, 5, 4, 3, 2, 1. Booster ignition. Full power engines and liftoff of the Falcon 9 and pace, helping keep pace with our ever-changing pollution in atmosphere.
Stage 1 propulsion is nominal.
All 9 rotor engines lit up and roaring. 1.7 million pounds of thrust. It's great news.
Power and telemetry nominal.
It's a steep climb into its orbit. View from the rocket camera.
Vehicle supersonic. Here we hear Falcon 9 supersonic coming up on max Q, maximum dynamic pressure on the launch vehicle.
Max Q.
Pass through max Q, the vehicle continues to perform nominally, all 9 engines firing.
MVAC engine chill has started.
Starting to chill the second stage engine to get that ready. They bleed a little bit of LOX in there so it doesn't get thermal shock once they light it up. A view there, looking down the first stage booster. Getting ready to cut off the engine and separate. We'll have a number of milestones all happening quickly in rapid succession.
We're about 10 seconds from main engine cutoff, and then we'll have stage 1, 2 SEP, and then stage 2 ignition.
Nico. Stage separation confirmed.
There it goes, the first stage of the rocket. Second stage now lighting
MVAC
up.
ignition.
Stage 1 boost back startup.
If you're here on the Space Coast and you're watching, get ready for a double thunderclap at just about T plus 7 minutes, 7 to 8 minutes. The double sonic booms of the first stage booster.
Fairing separation confirmed.
Looking inside, there go the fairings, revealing the PACE spacecraft to the elements. Now PACE will seek to get a signal on the TDRS satellite for our first acquisition of signal.
Yeah, this will be a downlink of a low-level signal on the TDRS network, utilizing the telemetry network to verify that PACE is the transmitter is on, and then they will continue monitoring the spacecraft until separation, and then be able to get their data once they get power positive that we'll see later.
And in that moment you just described, that time period that you just described, they'll only be monitoring data coming from the PACE satellite. They will not be sending any commands in.
Absolutely. Nothing until the spacecraft separates from the stage 2. The spacecraft team will just continue to monitor the health of the spacecraft using the TDRS network and looking at the telemetry. Everything so far on second stage is performing very well. Looks good on our trajectory. They just made a call. Somebody called ASO, but nobody's answered.
And there's a shot from the first stage booster as we're coming back down to the Cape. You can see the lights of the Space Coast. It's a pretty shot.
I love that shot. Seeing the coast of Florida come back into view.
2 more burns left.
Stage 1 entry burn startup.
That's the first one, the entry burn, for about 30 seconds. You see it lighting up now. Grid fins are out to help give it a precision landing, guiding the first stage booster back to landing zone 1. Split screen now. Well, we did have it. There's
Stage
a shot.
2 FTS is saved.
There's a shot of the booster coming back down from the ground.
Stage 1 entry burn shut down.
Stage 1 FTS is saved.
All right, and in comes the first stage booster. Second stage continuing on a nominal trajectory. You can probably see us in there somewhere.
I love that view at night too. To see it'll be really nice to see that as it gets closer. The coast of Florida as we come up on landing zone 1. Stage 2 continues to perform nominally. Great trajectory for stage 2 as spacecraft continues to look very well during this flight.
Stage 1 landing.
All right, there goes the landing burn. In just a few seconds, we'll have a booster on the ground. We hear the thunder here at
we
Hangar
hear those
80.
double claps.
Landing leg deploy.
Here she comes.
Stage 1 landing confirmed.
Another pinpoint landing by the first stage booster. Flight number 4 for the first stage in the books. Second stage continuing to burn on a 7.5 minute direct inject into orbit. This will be a quick ride, Mick.
Very quick as the continues to perform very well. We're looking for this to continue firing, and we'll get second stage cut off at around T plus 10 minutes, but things look very well on the telemetry. Vehicle's performing very well, and MVAC is nominal.
The second stage on a Cape polar trajectory hasn't been done by NASA in the past 60 years. SpaceX, though, has done it 11 times. This would be the 12th. T plus 9 minutes on the count. Just about 3 minutes left. Actually, check that. Just about a minute left on the stage 2 burn. There will only be one stage 2 burn.
Yeah, as Jimmy explained to us in the trajectory, this is a direct inject sun synchronous orbit. So just a single burn for the stage 2 this morning. And things continue to look well. Chamber pressure on MVAC and trajectory look nominal.
And then we'll coast for just a few minutes and separate the PACE Observatory. Standing by for stage 2 cutoff, known as SECO 1. We'll have that in just a few seconds.
MVAC shut down.
All right, there you have it. Now we're going to coast for a few minutes and take a look at the forward-facing camera so we can see the PACE spacecraft, which is being monitored by the spacecraft team.
Yeah, all telemetry on stage 2 looks nominal for the flight. Looks like a very good stage 2 performance so far. So we'll see how things go as we get ready for spacecraft separation.
Now just about 1 minute away. This is a big moment for the PACE spacecraft team. One in which they're holding their breath a bit. There you see PACE now.
I love that camera view from the front of the stage 2, looking at the PACE spacecraft out there in that dark space right now. Things are looking really well, and I love that. Love to see that camera view.
There goes PACE.
Payload separation confirmed.
Off into space on its own, flying free. We've got applause here at the Mission Directors Center at Hangar AE. Looks like a good separation. Vehicle pretty stable.
Yeah, launch vehicle performed very well today, and glad to see PACE separated. We've got a few more milestones that the team will be working on to get PACE to power positive.
Hopefully we can have this view for a bit longer. You see stacked to the right side of the screen, the 3 lines. Those are the solar arrays. It's a 3-panel array. And once the guidance and navigation control system senses that it's got basically nulled the rates, the spacecraft is stable, it'll start to deploy those solar arrays. And it will be done autonomously. We are now passing the milestone in which we expect the solar arrays to be deployed. Again, this is the expected milestone. Now you're looking at a view of inside the Mission Directors Center. That front row there, staffed by the team from the Goddard Space Flight Center, as they look anxiously at their monitors. The solar arrays are expected to take a few minutes to deploy. If it holds to the milestone, And so we just got word that they have confirmation the solar array deploy has begun. Again, solar array deploy has begun for the spacecraft. It's a 3-panel array. It's a critical milestone. And what goes hand in hand with that, Mick, is for the GNC, the Guidance, Navigation, and Control, to get that spacecraft and that solar array sun pointing. Can't do it yet because there is no sun in its current state. But we got a good ride into space. We will continue to monitor the nets here and the PACE spacecraft team. But in the meantime, we're going to send it back to Jasmine and Laura.
Thank you so much, Daryl and Mick. A beautiful launch followed by a smooth ride into space so far for PACE. Laura, what do you think?
It was absolutely stunning, and we are so relieved. Everybody in the PACE team has been cheering. All of our NASA colleagues have been cheering, as have all of you been cheering. So it is a great dawn for PACE and ocean and atmospheric sciences.
It really is. That was a great way to put it, Laura. So if you are just joining us, you are watching NASA's official coverage of the PACE launch. That's the Plankton Aerosol Cloud Ocean Ecosystem. It lifted off about 16 minutes ago aboard a SpaceX Falcon 9 rocket from right here on Florida's Space Coast. So now PACE is on its way to orbit 420 miles above Earth. We're able to collect data on both particles in the ocean as well as the air. Let's take a closer look at how those are connected.
Between September 2019 and March 2020, wildfires killed billions of animals and decimated more than 200,000 square kilometers of Australian forest. Some thousands of kilometers away, in the Southern Ocean, massive algae blooms covered a surface larger than the area of Australia itself. Just how are these wildfires and ocean blooms connected? To untangle that, we look to the carbon cycle. The carbon cycle is the flow of carbon between reservoirs in the atmosphere, plants and animals, land and ocean. If we look to the ocean reservoir, carbon dioxide is also absorbed by phytoplankton, microscopic organisms that convert carbon dioxide, water, and sunlight into carbohydrates like sugar and oxygen through photosynthesis. Carbon dioxide released into the atmosphere eventually becomes available for aquatic photosynthesis. But photosynthesis also requires nutrients such as nitrogen, phosphorus, and iron. Without the right proportions of these nutrients, photosynthesis doesn't happen, which can be seen in the iron-limited parts of the ocean, such as far offshore of Australia. Atmospheric aerosols released by fires, however, contain carbon as well as other nutrients essential for plant growth, like iron. When these aerosols are deposited on the ocean's surface, these nutrients become available for photosynthesis. This iron from the Australian wildfires is now thought to have stimulated the massive Southern Ocean phytoplankton blooms, blooms of such magnitude that they converted an almost equivalent volume of carbon dioxide released by the fires into carbohydrates and cellular material.
With an instrument like OCI, where you're measuring this full spectrum of color, all the colors of the rainbow you can imagine, we can start teasing apart the species and the different functional groups and different communities that exist.
The data from PACE will help define those communities, allowing for clearer connections within the reservoirs of the carbon cycle. These fires emitted a huge amount of carbon and other aerosols into the atmosphere. Those aerosols contained essential nutrients that are thought to have stimulated the rapid growth of phytoplankton in the Southern Ocean. And these kinds of connections can have big impacts.
It's really important to know where the carbon is going and where your food source is going. This is important for not just climate studies, but food security.
With data from PACE, we'll get a clearer picture of carbon as it links land use and fires, atmospheric aerosols and marine communities, and ultimately improves the data that we put into climate models.
NASA scientists are hard at work using data like what they'll get from PACE to better understand climate change. Megan Cruz is standing by with one of NASA's experts on climate science right now. Megan?
I am. This is Kate Calvin. She's NASA's chief scientist and also the senior climate advisor for the agency. What a beautiful launch we just saw.
It was beautiful. And it's so exciting to see this mission go and start to send us data soon.
Yeah, so let's talk about that. You know, PACE is going to advance our understanding of the Earth's climate and how it's changing so drastically, right?
Yeah, absolutely. So we're seeing, an increase in warming. The last 10 years have been the warmest since modern record keeping began. And that warming trend is driven by greenhouse gases, including carbon dioxide. And PACE is going to give us a better understanding of how the oceans absorb carbon and that exchange of carbon between the ocean and the atmosphere. It's also going to tell us a lot more about these tiny particles in the atmosphere called aerosols that can reflect or absorb sunlight and affect cloud formation, all of which is really important for climate.
So we're obviously going to learn a lot, but how can we use that data and turn it into how we address climate change?
So one of the important things, the more we understand about climate, the better we can predict it in the future. And we can take that and use that to help better plan. And that's something we're working on throughout NASA, is helping people understand what's happening where they live, what we know about what might happen in the future, and make sure they have that information ready at their fingertips. And PACE is going to help contribute to that.
And what I love about this is PACE is not the only Earth-observing satellite out there. And in particular, it's going to work with one that launched just last year, or a little bit over a year ago, that's really going to help us get a better understanding of our oceans.
Yeah, absolutely. So NASA has more than 24 satellites and instruments in orbit. They're each designed to measure something different. So we can see things like vegetation, carbon dioxide, clouds and precipitation, or oceans. And so you mentioned the satellite from a little over a year ago called SWOT, or Surface, Water, and Ocean Topography. So what SWOT's looking at is the physics of the ocean. So how the water moves, the height of the seas, how it mixes. What PACE is going to do is tell us what's living in that water. And they're both really important because the oceans absorb a lot of heat and carbon, and understanding how the water moves and what's living in it will help us better understand that.
And really quick, what would you say to the team right now as they're about to embark on a wonderful opportunity to learn so much for the Earth?
Oh, this is just such an exciting time. It's such a great mission. It's taken a while to get here, but we've launched, and in no later than 60 days from now, we'll start to have data, and it's going to give us information not just about climate, but about air quality, water quality, fisheries, harmful algal blooms, and it's just really exciting to be here.
And that's data we're going to share with the public, so that's exciting as well.
Absolutely. All the data will be publicly available.
Great. Kate, thank you so much. I really appreciate your time.
Yeah, thank you.
All right, so you guys have been hearing Daryl and Mick talk about waiting for power positive, so let's turn it back to them so they could walk us through that next milestone.
Thank you very much, Megan. Back here at Hangar AE, we heard some brief applause when we had the spacecraft separate, but now comes the big moment, getting that confirmation that the solar arrays have deployed and they're catching sun. We got a little ways to get there.
Yeah, absolutely. The team was very happy to see deployment off a second stage, and I know that the next big milestone for them is that power positive. So.
All right, there you see a look inside the Mission Director's Center as the teams wait for that telemetry to come in from the PACE Observatory, which is flying free now, T plus 23 minutes and counting. PACE launched into an orbital eclipse. And so once the solar arrays are presumably deployed and it comes out of the eclipse, the spacecraft will automatically orient itself towards the sun, and that's when the team will be able to see that power flowing through the solar panels at a rate that would tell them that it's sun pointing and it's in the right place.
Sun pointing and charging that battery back up. They've been on internal power, using that battery power for flight, and so that solar panel will help them get the vehicle charged back up and continue their mission.
That's right, those batteries are key, Mick. As we learned throughout the program, this PACE spacecraft orbits the Earth every 98 minutes. And as it does so, when it goes in from the sunny side to the eclipse side, those batteries help power it through the dark phase. And so charging those batteries are key to PACE carrying out its mission. If you're just joining us, we had a successful liftoff at 1:33 and 36 seconds a.m. Eastern Time from Launch Complex 40 here at the Cape Canaveral Space Force Station. We rode the first stage of a Falcon 9 rocket for several minutes before it separated, came back down to LZ-1 after about 7 minutes. Stage 2 of the rocket then flew pace for about 7.5 minutes, ultimately separating around 12.5 minutes after liftoff. And we watched as pace went on its own into space and separated from that stage 2. It was in the midst of an eclipse, so it was a quick goodbye. We saw it go off into the darkness of space.
Yeah, I'll tell you, the pictures from stage 2 were incredible. Not only watching pace separate from stage 2, but just continuing on its way to perform this exciting mission that we've heard all about this morning. But that video, just, it was exciting to watch that and be a part of this. And I know the PACE team is anxiously awaiting that power positive information. But, we got PACE where it needs to be and on its way. So this is a great start to the launch this morning.
Jim Free, NASA's Associate Administrator, is here on hand. He is there in the control room. You can see him in the second row in the middle, the fourth from the right. All along the first row, the teams from the Goddard Space Flight Center. They have a team back at Goddard that is online as well, the Mission Operations Center, and that's where the spacecraft will be commissioned. And it is also where they are sending commands and receiving telemetry at this very moment. I spoke to PACE Test Director Nusha Hagani, and she relayed to me that these are some tense moments. As a team watches and waits to get that confirmation that the sun is shining on the solar arrays and it's oriented in the correct direction. Once they get that confirmation, I'm sure we'll see a reaction from the team. According to the milestones, we are at the point in which the Goddard spaceflight team can command the spacecraft after waiting for a period of time as it came off of the second stage. That's so they don't get anything mixed up with the second stage of the rocket as it's going into a disposal burn and the spacecraft is going on into its orbit. T plus 29 minutes and counting. We are now into the moment where we would expect the milestone of power positive to happen, but we also know and have been told by the Goddard team that it could take a little longer.
Yeah, Daryl, I know as the spacecraft team is waiting for this information, the launch vehicle team has been doing a quick look on how Stage 1 and Stage 2 performed today, and so far everything is reporting in as perfectly performed launch vehicle today. As we saw in the video spacecraft step, Falcon 9 delivered pace where it needed to be. So that's good news on the quick look of the launch vehicle. And I know that the PACE team is excited to be where they are, just waiting for that power positive confirmation.
Great report out there, Mick. And as PACE was delivered to an orbit 674 kilometers, about 400 miles above the Earth's surface. PACE has 10 years of fuel on board to do its observations and report back its scientific data. But you never know with these satellites. They can go a lot longer. Just depends on how they use their fuel in the course of the next 10 years. Scientists, of course, always want more data. And many times they're rewarded with that when a spacecraft exceeds expectations, as often they do. Again, if you're just joining us, we are awaiting confirmation of a milestone called power positive. That milestone means that the PACE spacecraft has oriented itself into the sun and deployed its solar arrays fully so that it's getting power on all three panels so that it can charge its batteries and begin turning on the scientific instruments. T plus 32 minutes and counting. PACE spacecraft dimensions are 3 meters by 3.5 meters. It weighs 1,439 kilograms. Has a 3-panel canted solar array. And that solar array is the critical final milestone that will allow the team to take a deep breath and, of course, continue to monitor the telemetry trend. And all right, you can see the applause there in the Mission Director Center. The spacecraft team happy to report that they have power positive on the PACE spacecraft. Again, the final milestone, power positive on the solar arrays on the PACE spacecraft. That's great news. Congratulations to the PACE team.
Absolutely.
This is a big moment.
Successful mission. There we go. Excellent news. Spacecraft's happy. We saw some clapping. Things are going great. PACE is on its way. Power positive. That is a successful mission for PACE.
And just to recap, we launched at 1:33 and 36 seconds a.m. Eastern Time from the Space Coast here, Space Launch Complex 40. We rode the Falcon 9 for about 7.5 minutes and then got into space. We watched PACE separate about 12 minutes after that, Mick, and then at T plus 33 minutes roughly, we got confirmation that not only the solar arrays had deployed, but also PACE had aimed itself towards the sun once the spacecraft came out of a orbital eclipse, which was a big moment.
Very big moment, and very exciting to, not only get PACE on its way, have the launch vehicle perform the way it did, bring the booster back to landing zone 1. Daryl, I've told you this many times before, but this never gets old for me. I love this, and I'm just so excited for not only the launch vehicle team, but for the PACE spacecraft team. Very excited to see them on their way and get ready for this exciting mission.
A job well done by all today, and certainly now the PACE team can rest easy, but they're still working. The power team is going to stay on for another couple of orbits, which is another 3 hours, to make sure that they see that power data is trending in the right direction. And then, of course, commissioning of the PACE satellite will take another 60 days before they can start getting in some of that scientific data. But this launch, of course, the first launch for NASA's Launch Services program, but it is, as I understand it, the last launch for a very special member of your team.
Yeah, absolutely, Daryl. It's the first for 2024, but this is the last launch for our program manager, Amanda Mickiewicz. This marks an end of an era. It's a conclusion of a remarkable journey. Amanda, I just want to say you're amazing. Your leadership transcends the boundaries of Launch Services program and the Kennedy Space Center, resonating across the entire aerospace community. Even with your extraordinary achievements, you remain remarkably humble in your role. You always challenge us to strive for success. Over the past 14 years, you have steered the Launch Services program with unwavering dedication, maximizing mission success and contributing significantly to the evolution of the space industry. Your mentorship, your friendship, and your compassionate leadership style have been the driving force behind our team's pursuit of excellence. It is no surprise that you stand as a Divas Award winner, and your absence will be deeply felt. As your LSP family, we gather this morning on this, your final mission, to say, see you later. While we will miss you dearly, we hope you realize the profound impact you've had on each of us, the collective achievements, the shared memories, and the spirit of excellence you instilled within us are the testament to your remarkable leadership. As you embark on this new chapter of your life, know that your influence extends far beyond the boundaries of the launch pad. You are not just retiring, you're passing the torch to the next generation of dreamers, innovators, and explorers. The legacy you leave behind is not merely in the missions accomplished, but in the lives you have touched and the inspiration you've ignited. Godspeed, Amanda, and thank you for this extraordinary journey.
Great words there, Mick, and certainly well-deserved. Amanda Mickiewicz, Divas Award winner.
Yes.
One of the highest honors here at NASA. So from all of us at NASA, we wish Amanda well in her retirement. Well, that's going to do it for us here at Hangar AE, a successful launch of the PACE spacecraft and solar array deployment. Great success by all involved today. And now we'll send it back to Jasmine and Laura to wrap up the show.
Go PACE.
All right, go PACE for sure. Thank you so much for taking us all the way through solar array deployment, Mick and Daryl. So now we are back with yet another member of the Launch Services team, Denton Gibson. You are the Assistant Launch Manager from LSP. Thanks so much for being here.
Thank you for having me.
Of course, we're happy to have you. So today, this was your first launch in your new role as, Assistant or Backup Launch Director. How did things go from your perspective?
Oh, the launch went well. This is one of the cleanest launch counts that I've seen. The launch vehicle performed phenomenally. And we separated the spacecraft on time as predicted. And as you just saw, we got power positive. So the mission went flawless.
Great.
And that makes me very happy, of course. But tell us, what other launches does LSP have planned for this year?
So the other things we have planned for this year is the GOES-U, which will be coming up towards the end of April. And that'll be on a Falcon Heavy. And later on this year, we have Europa Clipper, which we're going to one of the moons of Jupiter, which will also be another Falcon Heavy. So we have 2 Falcon Heavies lined up this year.
Great. So a lot of nice things to see from LSP this year. We did just also see that beautiful tribute to Program Manager Amanda Mickiewicz. So, Denton, is there anything you want to say to Amanda and the rest of the team that worked on PACE?
Yes. Oh, first of all, I want to say, thank you to the SpaceX for giving us an excellent ride to space. And all the hard work and dedication that went into this from the LSP team as well as the Guarded teams. Did an amazing job to make sure that this mission was successful. And also our colleagues at the Space Force who, helped us out when we had some challenges with weather early on. They gave us a lot of good support from that, and helped us out on day of launch. And to Amanda, I would like to say, you will be missed. She's been a very good mentor to a lot of us, and to me personally, and she's been an amazing leader for the Launch Services Program. So thank you to the combined LSP, Goddard, SpaceX, Space Force team, and I know everybody will miss Amanda.
For sure. It really is a collaborative effort between all of you. Very well said, Denton. Thank you so much. And it was a beautiful, like you said, almost flawless launch campaign today. So great job for the LSP team. And for our viewers, if you missed that launch earlier in this morning, you are welcome to watch that again. We actually have a replay for you right now.
My 10,
9, 8, 7, 6, 5, 4, 3, 2, 1. Booster ignition. Full power engines and liftoff of the Falcon 9 and Pace, helping keep pace with our ever-changing ocean and atmosphere.
Stage 1 propulsion is nominal.
All 9 Merlin engines lit up and roaring. 1.7 billion pounds of thrust.
Chamber pressures on the telemetry and everything look good here at Darrell. 9 engines performing very well.
It's great news.
Power and telemetry nominal.
Makes its steep climb into its orbit. Could ride about 2 minutes on the first stage. A view from the rocket camera.
Vehicle supersonic.
Here we hear Falcon 9 supersonic coming up on max Q, maximum dynamic pressure on the launch vehicle.
Max Q.
Pass through max Q. The vehicle continues to perform nominally. All 9 engines.
Now that Pace is on its way, let's take one final look at this mission with some social questions for our ocean expert, Laura Lorenzoni. Thank you again to those of you that have been sending those in. So our first question comes from Huge XO on X. They ask, what is NASA going to do with the information gathered by Pace?
Great question. And NASA receives the data, and it is our job to distribute those data and make it freely available. NASA has a very robust open science policy, meaning that we want to make sure that everything that we collect through our satellites or our field campaigns is open and available to the public. And so we're going to have first flight for Pace in the middle of March, and this means that this is when the data is going to be available. But truly, Pace and Pace's data is meant to help the public, to help anyone, any citizen, decision makers alike make really smart decisions about anything that is important to them.
Right. It is nice to see that the data from Pace really is going to help the public. So our next question comes from Mondo305 on X. They ask, how will these studies help with coral reefs?
And that is an excellent question. The data from Pace, as we've been talking about, it really, one of the biggest instrument is the ocean color instrument. That tells you, what color is the ocean. And we've talked about phytoplankton. We haven't talked so much about sediment or about other things that are suspended in the ocean. And so coral reefs really depend on clear water. And understanding what kind of variations we have with respect to water quality, or that color of the water, is going to be really important for us to understand what conditions are really impacting negatively coral reefs and which ones are actually benefiting reefs.
Great. Thank you so much, Laura. We do have one final question. It comes from Mango Ali Ellie on Twitch. And they ask, how long is this mission and how long before the results are shared?
That is also an excellent question. Pace's original mission is 3 years. That is primary mission. However, as you heard through the broadcast, Pace has 10 years of fuel, which hopefully means that Pace is going to have a really long life. And NASA does have a lot of success with its missions, and they go into extended operations and last for a really long time, which is it's absolutely fundamental, as we've talked about, to really understand that climate trend and that climate record. And you can expect Pace data hitting our data repositories and being available to all of you by mid-March.
Okay, great. You heard it here. Mid-March is when we are going to be looking for that PACE data. We also have a QR code here to give you so that way you can look for where you can find that information from PACE. So thank you so much, Laura, for answering those questions. And thank you to the public for sending them in using hashtag AskNASA. We really appreciate that. So that's going to wrap up our coverage for the launch of PACE. I want to personally thank you, Laura, for being here, our ocean expert, to answer all of our questions. It's been a pleasure having you.
Jasmine, you've made this absolutely wonderful. So thank you so much. And thanks to all of you that tuned in. It has been a real privilege to be able to share this historic moment with you, and we really are standing in the shoulder of giants. If it wasn't because of the legacy that we've had on Ocean Color and all the people that have worked generation after generation on these kinds of technology, of instruments, we wouldn't be here. So thank you to all of you that have made PACE possible, and go PACE.
Yes, go PACE. It really is a collaborative effort. Thank you so much to all the teams that came together for this. You can follow PACE online at nasa.gov/PACE and by using hashtag KeepingPACE across social media. Thank you again so much for joining us. And until next time, go NASA, go SpaceX, and go PACE.
NASA celebrates Black History Month.
We are going. The history of this agency is marked